Concepts from our review that we did the other day having to do with sound waves. So for those of you that maybe would like to hear this again, or maybe you were absent, this might be helpful in preparation for your test. So what we're looking at is 4 different waves, and each wave is a snapshot of 1 second. So it's we're talking about how many vibrations in a given period of time, which is 1 second. So first of all, they're just asking for the frequency of wave A, B, C, and D. So all we do is simply count them. So if I count the number of waves in A, 1, 2, 3, 4, 5, and 6. So that one has a frequency of 6 hertz. B, 1, 2, 3, 4. 4 hertz. And wave C, 1, 2, 3, 4 as well. And the last one, 1, 2. So those are the frequencies of each of those waves pictured. Then we have some questions about those waves. Number 2 asks which wave is the loudest. When we're talking about loud, we're talking about amplitude. And in order to figure out the amplitude, we're looking for how tall the waves are. From that resting point, we're talking about the distance from here to the distance to the crest. We're not talking about from the crest all the way down to the trough. We're just talking about that distance right there when we're talking about amplitude, which determines loudness. So clearly, wave D is the loudest because it's the tallest, has the highest amplitude. Which is the quietest? We're looking for just the opposite of that. And it looks like wave A, if we're looking at the resting line, this looks like the smallest amplitude compared to that, and of course D is the highest. So we're looking at wave A, which has the highest pitch. This is where people really get confused. Pitch has nothing to do with volume. So now we're no longer looking at how tall the waves are. We're looking at which one has the highest number of vibrations in a given period of time, or the highest number of vibrations per second, which is hertz. So we're looking for which number here is the highest. And clearly, wave A has the highest number of waves because we counted 6 compared to 4 and 2. So the highest pitched sound would be wave A because it has the highest frequency, highest number of waves per second. On this picture, we're supposed to label the wave. The amplitude we just talked about, starting from the resting point. I'm going to draw that in. The distance from here to here is its amplitude. Okay, that distance right there. The wavelength is from one point on a wave to that same point again. That is a wavelength. The crest is simply the top. The highest point is the crest. And the trough is the lowest point on a wave. 6 just asked some questions. Number 6 asked, a really tall wave would sound what? A tall wave meaning high amplitude, it would sound loud. A wave with a small wavelength would sound, well, if it has a small wavelength, that means that the waves are really close together, and that would create a high frequency because you'd have a lot of waves. You'd have a lot of vibrations per second. So it would produce a sound that would be high-pitched. Sound travels like and we know that sound travels like a longitudinal wave. a series of compressions and rarefactions. Number 9, an oscilloscope picture looks like a transverse wave. So sound travels like as a longitudinal wave, but when we picture it on an oscilloscope, we see it as a transverse wave. Another thing that is kind of confusing. What is the unit of frequency? It's hertz. And number 11, what does the answer to number 10 mean? That just means the number of vibrations per second. Okay. Let's look at another thing real quick. I have 3 oscilloscopes pictured here and some questions. Which would have the lowest frequency? We're looking for the fewest number of vibrations, and clearly there's only one and really not even a half. So wave C would have the fewest, and that would be the lowest frequency, and that would be the lowest pitch. Number 2, which wave would have the highest frequency? Let's count these in A. We have 1, 2, 3, 4, 5.5. Sorry, you're out of view there. 5.5. And this one has 1, 2, 3, 4, and not quite back up to that 5. So highest frequency would be oscilloscope A. Which wave would have the lowest volume or the lowest amplitude or the shortest wave? We're looking at literally between this one and this one, and if I had drawn those a little clearer, it looks like C, but I think that the volume, if we're looking at the lowest volume, it would be between A and C. So I would say maybe A, because they seem to be a little shorter than this. Okay. Number 4, what is the frequency of each wave? Well, we said that this one was 5 hertz. We said this one was 1, 2, 3, 4, and maybe 3/4. Not quite 5. And we said this one was 1, maybe and a half. It's not quite a half, but we'll call it that. Close enough. Number 5 asks if wave A and C collide, what would happen? Well, this is where you want to look at, this wave starts going up, this wave starts going up. Whenever you have 2 waves that start in the same phase, which is either going up or going down, they are starting in the same phase. So that would be an example of constructive interference. So you would have a louder sound would be created. Louder volume. If wave C went down and wave A starts up, then you would have destructive interference and it would cause a quieter sound. Hopefully this video was helpful for you. Good luck on your test. Please ask questions if you don't understand. Have a great day.